Hello everyone. So today I am going to introduce some derivation of integration, the important formula for integration that is very important for boards and the entrance as well as. So first, for the derivation of integration of under root x square minus a square dx equals to x by 2 under root x square minus a square by 2 ln x plus x square under root x square minus a square plus c. So for the derivation of this thing, we have to first calculate the integration of sec x dx. So for the derivation of sec x dx, we have to rationalize first. Sec x into sec x plus 10x divided by sec x plus 10x dx. We can write it as a sec square x plus sec x into 10x divided by sec x plus 10x dx. Now as we know if the derivative of this term then the derivation is so simple. So let us y equals to sec x plus 10x, then dy equals to sec x into 10x plus sec square x dx. Here we can substitute the dy value. Now dy upon y, so the integration of dy by y equals to log y plus c. So we can substitute here the value of y log sec x plus 10x plus c, and now again we have to derive the integration of under root x square minus a square, okay, dx. So we have to derive this formula by the method of substitution method. That is, we can substitute the value of x equals to a sec theta according to this term, then dx equals to a sec theta into tan theta, and by the substitution of this term dx equals to a sec theta x sec theta into tan theta divided by under root a square sec square theta minus a square d theta. Okay, now we can write it as simply sec theta d theta. As we know that the integration of sec theta is equals to ln sec x plus 10x ln sec theta plus tan theta plus c. Now we can substitute the value of sec theta value. So the theta value is sec theta value x by sec inverse sec inverse x by a, and the tan theta value is tan sec inverse x by a plus c. Now we can write it as ln sec inverse x by a plus as tan, we can write it as tan sec inverse. Here we know the sec theta equals to hypotenuse by base, and the tan theta equals to p by b. So we can write is x square minus a square as a perpendicular, and base we can already have given. So base is equals to a and plus c. So we can write as ln x by a plus x square minus a square upon a plus c. Now we can write ln x plus x square minus a square upon a plus c. So we can write as a logarithm theorem x plus under root x square minus a square minus ln a plus c. If we can simply write it, these all terms like k means constant terms, so the integration of these under root x square minus a square equals to dx equals to ln x plus under root x square minus a square plus c constant. Okay, by using these formula we can derive the formula for the integration of under root x square minus a square dx. So under root x square minus a square. Now firstly we have to by part this term, like x square minus a square dx minus 1 by under root 2x square minus a square into 2x and x dx. So by the simplification it become x into x square minus a square minus these two terms are cut, and x square upon x square minus a square dx. So now x under root x square minus a square minus, we can simplify it as a square plus a square divided by root x square minus a square dx. Now it write as x square minus a square minus under root x square minus a square again minus a square upon x square minus a square dx, and these are dx. Now you write it as I, because I is already here and these I go in on this side, so it becomes 2I equals to x into root x square minus a square and minus a square upon and under root x square minus a square. As we know, the integration of these terms 2y equals to x into under root x square minus a square into ln x plus under root x square minus a square plus c. So I, these two terms divide on this side, so I equals to x by 2 x square minus a square by 2 ln x plus x square minus a square. So these are the very important formula for the board purpose and as well as entrance purpose. Okay, thank you.